So this is another thing to do with exponents, kind of like section 1. If you struggled with section 1, I'd encourage you to try to learn that stuff. So ask questions if you have it, but this exponent stuff is going to kind of build on each other, so don't get too far behind. Fair enough? Ask if you're getting stuck. So, okay, but want to first, so now we're looking at some different properties for like combining exponents. Before we typically would only have like 1x to a power, x to a negative 3 or something. Now, in a problem it's possible that you'll have x to the third times x to the fifth or something like that. So you have the x in there multiple times. So first thing, really, really, really important, that most of the mistakes I see from people often comes from this here, is an exponent only applies to the object directly in front of it. Unless there are parentheses. That the most common mistake that I see from people, and I'll just try to kind of squeeze it in here, is we'll get something like a xy squared. And people will look at that as though it's x squared and y squared, but instead it's just nothing's written after the x, so we can assume it's an x to the first and it's a y to the second. Fair enough? That if that 2 were to apply to the x, it would have to look like this, xy in parentheses and then the squared. Good? I don't know if that's worth writing, if that'll make a lot of sense even, but that's kind of what I'm talking about by that green sentence up above. So, cool. So simplifying exponents. That basically you're going to get problems that are saying simplify these as much as you can. You'll know you're done when you meet these things. So first, you have only positive exponents. So if you still have like an x to the negative 2 or a y to the negative 7, you need to take and move that x to the negative 2. You need to move the x to the other part of the fraction, make it an x squared. So, okay, each base only appears once. So you can't have an x to some power in one part of the problem, and x to an exponent in another part of the problem too. These will make more sense when we do a few. No parentheses. Because if you have parentheses, you could take and apply the exponent to everything inside. So by that I mean, if you want to, you could write this, no ab to the fifth, or something like parentheses with an a divided by b to the fifth. Because in both of those cases, the 5 is going to apply to the a and the b. You can kind of distribute the 5, so to speak. And number coefficients. Coefficients, those are numbers that are in front of a variable. So number coefficients in fractions are reduced. In other words, if I have something like a 2x to the third over 4y, 2 over 4 equals, if we're just looking at the 2 and the 4, what's 2/4 equal to when you reduce that fraction? 1/2. So we don't need to write the 1, agreed? We could just say, well, it would be an x to the third in the numerator and then a 2y in the denominator. Essentially, we're saying this becomes a 1, this becomes a 2, because x to the third over 2y. So we'll do a bunch of examples with this close to the end, and that'll really help, I think. I always struggled with how to remember these properties. I came up with a way that's maybe kind of hokey, but it worked for me in high school and in college and till I had it memorized. So how to remember these things. This is what I'd recommend doing is if you think of what math operations typically make the answers bigger. And I know you can kind of cheat by, well, what if you have a fraction or what if you have a decimal? But what math operations typically is your answer going to be bigger than the numbers you started with? Addition, multiplication, and one other one.
Subtraction.
No, not subtraction. Nice try. Exponents. Exponents typically make it. You're probably just not thinking of that as an operation, but addition, multiplication, and exponents. Which one of those is most powerful? Which one makes the answers bigger fastest? Exponents. So I'm going to say exponents. Exponents are the biggest. The next, well, say I have like a 2 to the third. A 2 to the third is 2 times 2 times 2, which is 8. What's the next strongest? Multiplication or addition? Multiplication is the next strongest. because a 2 times 3 is 6. Addition is weakest because 2 plus 3 is 5. So you kind of with me? The exponents, the answer is biggest, multiplication second, addition third. So for me, how I remember these things is I could take and in my mind put those in order if I had to. And I'm going to here, maybe I'll put it in red for dramatic emphasis, always do one step lower or one step weaker, you could say, with the exponent. Or with exponents, make that plural. And that probably makes little or no sense now, but it will soon. So I'm saying if you have something with an exponent, you're going to do multiplication with your actual exponents. If you have something with multiplication, you will do addition with the exponents. So then if you have addition, is there anything below addition? No. So then you can't do it. Nice. You can't do it. Okay. So these names, product of power, power of a power, I could care less if you know those names. They might come in handy a little bit in geometry if you need to do proofs, but I wouldn't worry about the names if I were you. But a product of powers, product means multiplication, right?
Yeah.
So what they're really trying to say is this, and I'm going to go through and on the left side of my line, I'm going to write the rule over here, and I'm going to kind of do an example over here on the right side. You're welcome to write the example, you're welcome to write the rule. It's up to you, write what you want to. But here's kind of what I'm saying. If we were to have something like a 3 to the 4th times a 3 to the 3rd, we want to take and we want to say that's going to be 3 to some new number up there. And the question is, what do you do to the 4 and the 3 to get this new number? Well, if you need to try to think through this on a quiz or a test, you totally draw a blank. 3 to the 4th, you agree that's 3 times 3 times 3. Agreed? And that's times 3 to the 3rd, which is 3 times 3 times 3. So 3 to the 4th times 3 to the 3rd is 3 to the 7th. Yes? So what do we do to the 4 and 3? We add them. That this becomes a 4 plus 3 or a 3 to the 7th. And you could figure that out doing this if you had to. But what we're doing is, if you go back to what I had here, we're multiplying, agreed? We're multiplying these things. Well, if you're multiplying, you always do one step lower addition with the exponents. The official rule is this. They write it as b to the m. B just stands for like the base of the exponent. So b to some power times b to the n equals b to the m plus n. We take and we add those two exponents together. So this is officially how they write it. The main thing I'm concerned about is when you get a problem like this, do you know that's going to be a 3 to the 7th? Or if we were to replace all of those with x's, if I have an x to the 4th times an x to the 3rd, that's going to equal x to the 7th. Agreed? Okay. Power of a power. So power of a power, what we mean by that is going to be something like this here. Let's say I have a 3 to the 4th, and that 3 to the 4th power is going to be squared. Do you agree that's 3 to the 4th times 3 to the 4th? This first one is going to be 4 3s, agreed? Times the next one, which is 4 3s. So this thing here has to be 3 to the 8th. What do I do to my 4 and my 2?
Times them.
Multiply them, yep. And that goes up to what I was trying to show above. We have an exponent to an exponent, so it's kind of like we're at this step. Always do one step lower with the exponents. So when they're doing an exponent with an exponent, we're going to multiply the exponents. So the way we write it is b to the m in parentheses to the n power equals b to the mn, or m times. You could do a little multiplication dot in there if you wanted to. B to the mn. Good so far? If we go back to what Luke was saying, I don't think I have it in here, so I'm just going to write it over on the side. If we were to have a, we'll do b's, why not? You could keep it like 3 to some power, but if you have like a b to the 3rd plus b squared, can we combine those? Nope, because that's kind of like this addition thing. Well, there isn't a step below addition that makes the answer typically larger. So we can't combine that to a b to some power. That right there already is simplified, so that would be your answer. Probably not worth writing. I wouldn't stress about that a whole lot. Let's jump down to this last thing. The power of a product. By that, they're doing something like this. 3 times 4 to the second power. And you could try to reason through this a couple ways. Do you agree that's going to be 3 times 4 times itself? That's the same as, whoa, all kinds of crazy stuff going on in here. Nice hero, huh? Not exactly sure how it happened, but okay. So this here is the same as 3 squared times 4 squared, because I've essentially changed the order. You have 3 times 3 times 4 times 4. What we're really trying to say is this. Do you agree the 2 applies to everything inside? Yeah. Okay, so the way we're going to write that is typically they do, let me just scroll up a little bit. They'll write it as A, B in parentheses to the M. And that's going to be A to the M times B to the M. Then we still keep it multiplication, but I just kind of view it as though this M gets distributed inside. Technically, you probably can't call it distributive property, but the M applies to everything inside. Can I keep going? Give people a second to finish writing it. The big thing with the practice stuff or with the homework is don't get intimidated by it. Just take it in little steps, and you'll be fine. Don't stress about the stuff. Okay. 5 to the 4th times 5 to the 3rd. That's the same as 5 to the 7th. Typically, you're not going to see ones like this. We're going to give you variables instead of the 5s, instead of numbers. Just want to start with something that looks a little more comforting. So 5 to the 4th to the 3rd power, that's going to be 5 to the
12.
They did an exponent. What's one step lower than an exponent?
Multiplication.
Multiplication, yep. So 4 times 3 is 12. So 5 to the 12th. Good. And you could even, if you wanted to, until you get used to this, you could over on the side write exponent, multiplication, addition, and then just look at that and know it's always going to be one step lower. So ideally at some point you kind of work your way out of that, but if that's what it takes to get you to master it, then start with that. So, okay. X to the 2nd power to the 3rd power. This one right here is going to be a x to the 6th. Yep. So they did a power to a power, so a step below exponents is to multiply. Next one is x to the 18th. You guys agree with that?
Yep.
Okay. Then my next one, x to the 9th times x squared. They're multiplying, so we are going to add. Becomes an x to the 11th. Good. Good, good, good. Now you have a couple options here. How do you want to do this baby here on the right?
Add all.
If we, not at all. Can I hear an amen? Okay. If we were to add them, that would give us an x to the 2nd. That's going to be by far the easiest. If you really want to go crazy, and most of you are kind of like, no, just keep going. But do you agree we could take this x to the -1 and put it down below? And that would be an x to the 1st. And in hindsight, we don't learn what to do with that until tomorrow. But that's going to equal x squared. So moving on. Sorry for wasting your brain cells, wasting oxygen. Okay, this next one. X to the 3rd times x to the 7th. When we add those two, we get an x to the -4.
Why?
Because we're doing 3 plus -7. So 3 positives, 7 negatives. There's 4 more negatives. But we can't stop there. Going back to page 1, it's not simplified until you have all positive exponents. X to the -4 equals
1 over x to the 4. X.
perfect. That you could look at that as though it's over 1. The negative exponent means put it down below. And then the exponent becomes positive. This next one for a next step is x to the... Nice. They did the exponent, so we do one step weaker. We multiply. And when we have a -6, that's going to equal...
1 over x to the 6th.
Nice. 1 over x to the 6th. Because we could view that as though it's over 1, but then the -6 means that has to go down below and join the 1. And then we have to put a 1 in the top. Can't have a fraction unless there's something in the numerator. So, next one is x to the...
8.
Thank goodness she's positive. Anybody else think that? Let's let us be done. So, okay. Ooh, look at this next exciting adventure. That's called phrasing it positively. Okay. What do you want to do with this one? Speak to me.
Add them all together. Add the A's together.
Perfect.
Yeah, add the A's.
If we combine those, that gives us a a to the negative 2. And you agree?
B5.
Yep. The b to the fifth just keeps hanging out. Doesn't, just kind of sits there like a slacker on their parents' couch. So
B5 over A squared.
I love it. B to the 5. So he sees that that's a positive. So b to the fifth stays. The negative 1 goes down below, but only what's to the negative power becomes an a squared. But just steps you've been doing, right? Just baby step your way through it. All right, next one. A, B, C. Can we combine any of them? Nope. So a to the third just sits there, right? Maybe I should just say, what goes down below?
B to the negative 4.
Yep. So this here, because it's negative, drops below. The other two are positive, so they stay up top. B to the fourth. So we're kind of combining this and the next section. This next one. You could go and take this and move it down below first and then square everything. My guess is most of you wouldn't do that first. I'm guessing most of you would. Yep. That 2 applies to both, right?
Yeah.
So I'm going to write it this way, but most of you probably wouldn't. Just so I don't lose anybody, though, that we have this a to the negative 3 squared, which is a to the negative 6. Most of you just look at it and go right to a to negative 6. And then I have this b to the 4th squared, but most of you just in one step say that's b to the 8. I guess either way, are we all at least up to this thing right here? Okay. Last step, we need to get rid of that negative 6. So we take that and drop it down below, right? B to the 8th over a to the 6th. So, still good? Final one. Final chance to work your magic.
A over B to the second.
A over B squared.
Nice. I totally thought I'd lose some of the people, especially the fast ones there. Because a lot of people, they take that negative 2 and they want to apply it to both. That was supposed to be my trick. But both people that answered just moved the B, because the A is just a to the first power. So nice. Nice, nice, nice.